Awesome. Thank you everybody for coming. My name is Marion Forrester. I am in the Denver, Colorado, USA area, which is the Kingdom of the Outlands. I've been a part of the SCA for about 24 years now, I believe, and have been making paint for about 10, 15 years and have been studying paints and pigments for about 6 or 7 years now. And a few years ago, I got my laurel for doing just that. So how do we know what pigments were used? We have lots of different clues, and some of them are very apparent and some of them take a little bit more. So we have sampling and non-destructive analysis for paintings and manuscripts. We can either use a little bit of sampling where you take a tiny bit of the paint and run tests on it to determine what was used, or you can do things like Raman microscopy. Go talk to Dad. Sorry about that. Another way we can find out about what pigments were used is through the manuals that they left. Some people wrote down how to make different pigments, and these are not always right on. Sometimes they left out a few things and we have to do a little bit of interpretation. But that's a really good clue as to at least what kind of materials they were using, if not the exact process. Next, we have the manuscripts and paintings themselves. Sometimes they actually included the process of them making that, or they have palettes with the materials that they used next to the pictures. We also have trade documents and other sorts of written accounts like correspondence, ordering different pigments to use on different projects, and wills and inventories. We have a really nice one about a lead white manufacturing facility where they had all the equipment that they were using. So we kind of have an idea of how they were making this, and also archaeological evidence. There is a shipwreck off of, I believe it's Croatia, called the Nalik. And in that one, they found pigment balls. They found all sorts of different forms of pigments. And so we can actually pull those up and see what they look like. And it's pretty fascinating. So what forms did they store these in? They could have been in a powder. Some were stored underwater because they can be reactive to oxygen. Some were stored in clothlets, which are little pieces of cloth, usually treated with alum to help the pigment stay. And then when you're ready to use it, you put it in a little seashell, a little bit of that cloth in a seashell with a little bit of binder like gum arabic, and you can bring that color out of there and use it. And sometimes they had different shaped lumps of, we have accounts of truncated cones and balls and all sorts of different cool things. So I'm mainly classifying these as organic, inorganic, and manufactured. Organic is plants and animals. Inorganic, we're talking soils, metals, rocks, and manufactured are things that you have to use a little bit of a process to get your pigment. So things like lead white, verdigris, that kind of thing. So they had a lot of different colors that they used, some at different times in different places. Generally, as we look at history, they seem to have moved more from minerals to more lake pigments, getting in a little bit more of the botanicals, which didn't always last as long, but were beautiful and they were cheaper. And more manufactured pigments. And this is just a general overview. There are more like dragon blood and all sorts of different wonderful colors. So we'll start with organic. Things like kermes and cochineal, which are bugs. Lac is also from a bug. Madder root, Brazil wood, indigo, and woad are all botanical, and then we have carbon black, which could come from multiple different sources. So we'll start with kermes and cochineal. It's sometimes hard to decipher exactly what they were using. So kermes was mostly used earlier in period. It makes a beautiful red color, and this is from a little insect that feeds on the leaves of oak trees around the Mediterranean shoreline, and a little bit in northern Africa. The problem with kermes was you didn't get a whole lot of color for the amount of pigment material you had. So so it was really exciting later on when cochineal started coming from the New World. Now, they did have cochineal coming from the Old World, Polish cochineal, Armenian cochineal. We do have evidence that Armenian cochineal was used in manuscripts. A lot of these things can also be used as dyes, and some of them were mainly used as dyes instead of as pigments. And the difference between a dye and a pigment is a pigment will kind of sit on your material. So if you think of a paint, it kind of sits on your paper. You need a binder to get it to stick nice. And a dye will go into your material. Think about with cloth, it goes into the fiber, wraps itself into the fibers, and it's right in there. And so a lot of the times when we talk about dyes, that's with fabric. A lot of times with pigments, we're going to talk about manuscripts, things like that. So it was really exciting when we started getting cochineal from the New World. It had been used there for a very long time, especially in Peru. And that's where we figured that that area was where cochineal probably originated and then started to spread through Central America and Mexico. Cochineal has a much greater pigment output than kermes. So you get a lot more color for the amount of bugs you have. Cochineal is a cute little bug. It's a scale insect that lives on Opuntia or prickly pear cactus. And these things, it's only the females that produce the beautiful red color. You scrape them off, allow them to dry, and crush them up. You can use it both in an ink, you can use it as a dye, and you can make a lake pigment out of it or other kinds of pigments. So, and we have documents of just great big sackfuls of cochineal coming from the New World into Europe in the 1500s and 1600s. In 16th century, it was being transported from where it was being made into a pigment to where it was being used mostly in fabric clippings. Earlier, it was being used, being transported in lake balls. So a lake pigment is when you take organic dye usually, and you want to make it into a pigment. So you have, through a chemical reaction, you get that to bind to some sort of calcium carbonate, something like chalk or ground eggshells, and that makes it more of a pigment instead of a dye, and it allows it to stay nice. And this is it's fairly fugitive, but I've had really good luck with it staying quite a while. We have evidence of cochineal from Peruvian wall hangings and things like that for quite a while. So it's not overly fugitive. Also, the British redcoats were dyed in cochineal, so that'll give you an idea of the beautiful red color that you can make with that. Madder root, I know it's been mentioned before in other classes. Rubia tinctorium, it has not only been used as a pigment, but also as a dye substance for cloth and leather for a very, very long time. We have evidence of Pliny the Elder talking about its cultivation in Rome, and Charlemagne in the 800s included it in one of his documents and encouraged people to grow it on their land to be used as a dye. It seems like Flanders was a big area for growing madder root, but it could be grown all over Europe. And it kind of makes it can make a red to reddish orange to pink color. Brazil wood was one of the more interesting ones. It's very pH sensitive. So in the picture there, you can see there is a recipe for Brazil wood in 4 colors. So depending on what you add to it, like cream of tartar or alum or whatever, you can change the color dramatically. The orangish color is what comes from just soaking the Brazil wood in water. And then if you add alum, it gets to be a little bit more redder, and the tartar is the yellow. And so originally this came from Southeast Asia, but when the Europeans went to the New World, they discovered that there were these big trees that made about the same color. So they called the trees Brazil wood, and they called the country Brazil. It's the heartwood that produces the dye, and this was used quite a bit. I have made everything from like almost a purple into almost a pink with changing the pH on this. Lac, again, it's an insect, or rather the resin from the insect. If you hear of lacquer, that comes from the same insect, Caryolaca. They live on ficus trees mainly, and they've been used forever to create colors all the way back to the 4th century BCE in Sanskrit texts. The main producer was India, so you have pigments coming from all over the world to come to Europe to be used into manuscripts and things like that. And it's kind of confusing because lac can be the insect resin. Sometimes it's called lake. And lake can be also used for all of these other organic pigments that were used. So one of the confusing things with pigments is the terminology, including with blues. So both indigo and woad were used, but sometimes it's hard to figure out which one they were using because they both can be referred to as indigo. The Asian indigo is often called Baghdad indigo because that's where it was coming through. It was primarily grown in India and the Middle East in that period. And there are all different plants that produce indigo dye. These are just two of them that were used quite a bit. And that Baghdad indigo is Indigo Ferra tinctoria, as opposed to Woes, which is Isatis tinctoria. Tinctoria just means it's a dye plant. So you're going to see that a lot with plants that are used to create pigments. Later on, the true indigo or Indigo Ferra tinctoria was grown in Guatemala and El Salvador, and a lot of the countries that were doing a lot of the exporting were those that were just doing a lot of travel across the ocean at that point. Italy, Spain, later Portugal. Woad was produced all over Europe, but the problem was it didn't produce as much pigment as the true indigo does. So again, it's just like the Kermes and the cochineal. England especially liked their woad and did a lot of production and tried to protect their production, and tried to ban all true indigo coming into the country for quite a while. And a lot of times when you see it, indigo is used in a lot of things that we didn't know about, but with sampling, we're now finding out that they're indigo instead of things like ultramarine. Things like cornflower or other pretty flowers, you could just go through the fields and pick flowers and make dyes and pigments out of them. Cornflower was one of these, Centaurea cyanus. A cyanus is blue. I believe this one is an anthocyanin, yeah. Sensitive to pH. It's blue unless you add alkaline substance, and then you're going to get green. And you're going to get that with quite a bit of blue materials. So to make the pigment, you extract the juice and combine it with gypsum or white lead, which is pretty standard. There's a lot of different manuscripts that you can find these recipes for. And there's also all sorts of other things that they're using about the same process to get anything from red to purple, like bilberry, elderberry, red poppies. And yeah, if you're interested in that recipe for just taking a walk, gathering flowers, and making pigments, that's in the manuscripts of Jehan Lebeg. And you can find that in the Merrifield book, which I should have at the end of the presentation. And one of my favorites to make is iris or columbine green. They often called it lily green, and this one was a later in use pigment. Lots of different recipes for it there. The basic recipe was to extract the juice and then make either a pigment in a shell or clothlet with it. And adding alum would start changing the color from blue to green. And then the calcium in either a seashell or you could add calcium oxide, and that would change your color to anything from like a forest green, hunter green, to really, really deep green. And again, that's kind of a fugitive one. This is one that I've kind of been playing with lately, is Turnsole or Chrozophora tinctoria. It's kind of hard to figure out exactly what recipes are using this, but your big clue is that it's a plant with triangular seeds. Those are actually the seed pods, not the seeds. And you can get anything from red, blue, or purple out of this. And it's an artist pigment and dye. And I think this is the last of the botanical ones, this is Orchil or Orcine, and it's a lichen dye. It was discussed in the last class on here. Again, we're getting anything from a purple to red. A lot of the export seems to be out of Italy, and it was also used as a parchment dye. I believe there's a red or purple manuscript that all the parchment has been dyed with Orcine. And I've been having problems getting a nice color out of this. And I think it may be I live at a higher altitude and we don't have as much oxygen. So you're trying to get it ferment, trying to get the dye to ferment to change color, and it is not fermenting for me. Oh, we also have sap green and buckthorn yellow. Sap green is also called pasta verde or Devetia. And if you see still de grain, that's probably the buckthorn yellow. Lots of different manuscripts mention this one, used as a paint dye for cloth or leather. It's kind of an orangey yellow. Also seems to have a little bit of a green tint to it. Weld, here in Colorado, we have Weld County. Weld grows, and it's an invasive exotic here. You may see it quite a bit as Arzica or dyer's weed. It's greenish yellow, used as a fabric dye as well as a pigment. It's mentioned by Cennini, so if you or Cennini, so if you see that in Cennini's book, it's a really nice. The Dover version is about $12 in the US. So it's a very easy manuscript to get started if you're interested in pigments. And the Bolognese manuscript tells you how to make a lake pigment out of it. Saffron. Not the most best for staying. It's pretty fugitive, but it's a very beautiful color. You can get a nice kind of egg yolk yellow out of it. And it's pretty translucent. It's made out of the anthers of the fall crocuses. And again, like pigmentish stain. If you want to make a really quick, easy pigment, throw some of those anthers into some water with a little bit of gum arabic, and you will get a really quick stain out of that. And another one of my favorite pigments to make is carbon black. You can make this through all sorts of different things, and you're going to get a whole bunch of different colors of black. Some of the bone blacks are a little bit more brown, and then some of them are going to be much deeper bluish, like the peach pit or the almond shell. I have ivory on that. It's mammoth ivory, so it is not illegal to use as opposed to like elephant ivory. With these, you're putting them into an oxygen deprived container. I use a pipe fitting with 2 end caps on it, throw it into a nice hot fire, and it takes about an hour for me to get a nice black out of this. You can hear it when it's done. It kind of has a little tinkle as you move it around, and if you break your material, it'll be black all the way through. And it's just a quick, easy matter of crushing it up and adding your binder, and you have paint. Okay, so I'll take a quick little break here. Do we have any questions?
One comment just showed up in chat. I use a Dutch oven with a lid sealed with clay.
Yeah, and that's very close to what they would have used. They say casserole luted with clay, so that's very, very close to what they would have done. Okay. Inorganic, we're talking things like soil and minerals. And these are nice and light fast, so they're fun ones to use because you don't have to worry about keeping them out of sun. Malachite or azurite. They're very close chemically, and they're pretty easy to make. The stones are not too hard, especially if you get them in nice long needle-like crystals. It's called all different things, like mountain green, and these were used throughout the medieval period and pretty much all over the world. Places like Egypt, they were used for a very, very long time to make beautiful greens and blues. Azurite, and there's an example on there, is both azurite and malachite. And one of the problems with manuscripts is that you're just going to have it's azure, and they're not going to tell you if it's azurite or if it's ultramarine or anything like that. Sometimes you can tell by where it came from. If it has like lapis armenius or something like that, it's probably going to be azurite. Imported from Germany, often referred to as Alman blue. And some sources have said that it may discolor to green or darken. That doesn't seem to be a huge thing. This was actually the major blue that was being used in period. It wasn't the ultramarine, because that was too expensive. And used throughout the period, beautiful blue, but if you grind it too much, it can turn gray. So it's both azurite and malachite will do that. So you have to be very careful in grinding it. You want the larger the crystals, the more it's going to refract blue light. Ultramarine, expensive because it was coming from Afghanistan, and still most of our ultramarine or lapis lazuli is coming from there. Specifically the Badakhshan mine in Afghanistan. It was shipped through Constantinople or Persia and then on to Venice. Venice was huge for being a distribution center for all sorts of pigments and colorants, for everything from dyes to cloth dyes to glass. And the way you can kind of tell that they were using ultramarine instead of azurite is in how they were preparing it. They were refining it and getting the calcite out of there using beeswax gum, gum mastic, pine rosin, that kind of thing to make it into a paste, and then extract the blue while leaving the clear calcite in the gum mastic mass. And beautiful blue. Orpiment, one of the problems with a lot of these mineral pigments is that they have some messy things in them. Orpiment has arsenic in them. So when you are preparing these kind of pigments, you need to be very careful about your area. And orpiment, Chinini, I believe this is the one that he's like, just don't make it yourself, just buy it. It's a lot safer that way. So I suggest that as well. If you're using orpiment, just buy it. Don't try and grind it yourself. Much more common in the earlier part of medieval history. It seems like later on they were using more organic yellows. And a lot of these minerals seem to be coming from Austria and Germany, also being imported from Kurdistan, Syria, and China. Earth pigments can come in all colors of the rainbow, everything from white, yellow, red, green, blue, purple. Found all over, but some of the areas produced certain colors that are that gave the pigments their names, like sienna or Verona green. Uh, Bull is a red earth that was used a lot of time in gilding, also used as a pigment. Green earth was coming a lot from Italy. And you could change a lot of these by heating them up or roasting them and changing the color. They would turn more red and less brown. You were creating an iron oxide there. And we're going to finish up on our manufactured pigments, things like vermilion, smalt, verdigris, lead pigments. So vermilion, you could get it as just a mineral in cinnabar, and that was something that was used all over the world, especially in China. Produces a beautiful dark red. Cinnabar in Europe was being mined a lot in Spain, all the way back to Roman times. And we know that they knew how messy this could be because it has arsenic or mercury in it. Pliny the Elder says that people in the mines would wear masks to help protect themselves from the dust when mining cinnabar because it was very poisonous. It was traded by the Crown of Aragon in Spain and Italy, later Castile, Spain. You can get the same color by manufacturing it. And anywhere where you have sulfur and mercury, you can make this. Spain, as much as it mined earlier, later on it became an important producer of this. And sometimes different areas would produce the pigments and they'd become known for their quality. Antwerp was a big producer of a beautiful vermilion. Lots of recipes exist, and this may turn black. This is one of the things that you do not want to put too close to lead, or you may have some chemical reactions going on. Smalt was used later in period, and it is not something that's great with oil. It can darken when used in oil. It was a lot cheaper than the minerals that they found. This is a vitreous substance, which is pretty much its ground glass. So it's a little bit more transparent than the mineral pigments, but it was a lot cheaper. Yeah, so one of the big productions was from Italy, especially Murano or Venice. And if you look at those and you know about art, these are cities that are also known for glass. So it's not very surprising. A lot of the mineral that was used to make this was coming from the German area. So again, it's being mined in Germany and being manufactured in more of a glass producing area. Verdigris, I was a little bit surprised to find out how much verdigris was actually being traded, considering you can make it so easily whenever you have copper and some sort of acid like vinegar, or they also would use urine or the waste from making wine. You can get anything from a green to a blue out of this. There are some recipes that say that you can use silver. That's not going to get you a blue. I think if you were getting a blue, it was probably from impurities in the silver. France was a major production center, and also Hungary and Germany, not surprising because they were doing a lot of mining. Lead white. Again, probably not the best thing for you to make on your own, probably something you want to buy. You can still buy it very easily. There are all sorts of words for this: flake white, cerusse, Bianca, Blanchette. you can use it in all sorts of different kinds of paints. It's also used in making lake pigments, like the cornflower. Yeah, a lot of this again was coming from Italy, where they were making a lot of different colors. Oh, and it was used in gilding as well. Just kind of a overall nice deep white. It was not transparent. It would also help to dry oil, so it was very helpful in those kind of things. You can change the color of lead white by heating it up. You can make it go yellow and then orange and red. Again, be very careful when doing these kind of things. It's better just to buy them. And back in the medieval and Renaissance, they could buy them from England and Germany and all sorts of places. Another beautiful yellow that we're finding more and more is lead tin yellow. It may also be called massicot or giallarino. Some translations figure massicot's lead yellow oxide, but a lot of them say it's lead tin yellow. It's a beautiful pale yellow. It was also used in glass. Again, same as like smalt. Mostly used later in period. A lot of these manufactured were used later in period, except for things like lead white was used quite early, as well as verdigris. And here are some of the resources you can use to find out more. I've got a lot more resources if you're interested. You can also go to my website, and that'll give you a whole bunch of my research. And I also encourage people to join Period Pigment Palette if they're interested on Facebook. I am a moderator for that, so.
We have one comment in the chat.
Awesome.
When you acid test silver, the copper in the alloy will etch out. So is silver very debased? It could work for verdigris, possibly.
I have tried silver using verdigris, and yeah, you get nothing. If you use copper or brass, there's mentions of like copper filings, all this kind of stuff, but I've put silver in with an acidic vapor and I do not get any color. So I'm figuring that that was probably some sort of impurity in the silver that they were getting blue out of that.
Sorry, yes, I'm a goldsmith. I was trying to explain if silver
awesome.
was debased enough. So silver could be alloyed with other materials, usually
Yes.
copper, and still look very silver in the time period.
Yes, yes.
And so when silver is very, very debased, it will still look very silvery on the top surface. But if it's got more than like 10 or 15% copper, it will actually oxidize the verdigris color. So if you put it in acid tests, it fizzes and you get that beautiful blue green. So so your silver will be lovely silver and not as awful as some of the quote quote silver that would have been floating around as maybe less reputable coinage in medieval times.
Yes, absolutely.
There's a comment saying Period Pigment Facebook group is great.
Awesome. So glad it's helpful for you. And we can stop the recording now.